So yesterday we got to play around with Desmos and understand a little bit more about what's going on with that and understand what's happening. That's a good thing to be able to look through those graphs and see and adjust and kind of play around. That was yesterday. Today we are doing an introduction day. It is not something that you will be an expert at by the time we leave. Okay, again, this is something I'm going to teach that you're going to learn in Calculus BC. If you're in Calc BC right now, you'd be doing the exact same thing. I'm going to teach you some skills that you can do right now that will help you next year when you're trying to get through these. Okay. A lot of it is using the tools that you have to figure out a difficult answer. That's what our focus is today. So keep that in mind as we work. All right. Make sure you're using your calculator because we're going to need it all day today. We are graphing r equals 4 sine 3 theta. And then we're trying to trace the graph in the same order that it was given. Let's do it. If I'm trying to graph that thing right there, what shape am I going to have? It's a rose. How many petals does it have? Rose with 3 petals. We can tell that because of the 3 right there in front of my theta. It's an odd number. We keep it the same. Show me with your hands. What type of symmetry does that graph have? It's a seal graph. It has y-axis symmetry. I almost said walrus again. Y-axis symmetry. It's a maximum. It's alligator. Alligator and seals. It makes total sense. Maximum R. Show me with your fingers. What's the maximum radius you can get? The maximum radius you can get is 4 because you got that 4 out in front, and then you want to figure out where can you find it. So to do that, you are thinking, when is sine of 3 theta going to get me 1? Because if this is 1, then my maximum is going to be 4. So if I do that, I do inverse sine. When is sine going to get me 1? 90 degrees. Then I divide by 3, divide by 3. Theta equals 90 divided by 3 is 30. That is the angle that I'm going to have a maximum. Not all of the maximums, but a maximum. If we were to put this on a good old T-chart, I've got radius and thetas. I'm going to have 4 petals. I know one of them's at 30 degrees. 30 degrees would be right there. What can I do here, Joey, to find my next petal? 360 degrees. That's how big a circle is, and he divided it into 3 petals. Because we have 3 petals each, we take 360 divided by 3, and that would tell me that each petal is going to be 120 degrees apart. Wonderful. So if that one's at 30, when's my next one going to happen? 150. We add 30, get 150. Boop, right there. And then my last one is going to be at 270. We just add 120 again. We're down here at 270. We're also going to touch the middle. If I want to see what the picture looks like, let's graph it. So let's clear this stuff out. We are graphing 4 sine 3 theta. Theta. All right, there we go. I'm going to hit graph. My calculator is pretty fast, so it goes probably faster than you can see. So I'm going to go to window. You don't need to do this, but I'm just going to slow it down so you can see the pattern here. There it goes. It works its way around and goes through. You can see that the yellow thing in the corner was still working afterwards because it started repeating. If your eyes can't do that, hit the trace button. See this trace button right here? Hit that button. If you hit the trace button, I don't use trace on any other graphs but polar graphs. But with polar graphs, it's really handy because if I do it and I just hit the over arrow, it's going to follow the pattern. Like I started at 0. I can't go any further left. I'm starting at 0. Right here, it's telling you what the theta is. But I started at 0, and I'm going to work my way around. So I get all the way to there, and then I zoom right back to it, around to there, and so on. You can kind of see the pattern that it's working on. Okay, so let's go ahead and draw it. We started here. We worked around, and back. Yeah, I know, it's great, isn't it? It's super fun. Great. Everybody follow what I did there? I graphed that thing. technically I just want to go from 0 to pi. Because if I do 0 to 2 pi, it starts repeating. If I change my window to 0 to pi, I get that same thing. Oh, sorry. 0 to pi. I get that same graph. Nothing's going to change. It just stopped in the middle. What if I asked you, what would you need to change your window so that you only got that section right there? Talk with your neighbor. Think about what would I need to change my window to get just that bottom pedal. Talk to each other. Figure it out. We were trying to figure out what we thought the windows should be or what our thetas should be in order to get us that graph. Anybody have a good guess or good idea as what they think it should be here? What do you think, Max? So pi over 3 and 2 pi over 3. How'd you come up with that? That seems pretty specific.
I saw how to graph each one individually in 3 parts, and so I kind of split it up into 3 parts. I said, well, the blue on the right is the first one, so that'll be between 0 and pi over 3. One in the middle is between pi over 3 and 2 pi over 3.
Perfect. Perfect. If you're at home, you couldn't hear him. He said we graphed from 0 to pi, so it was a full pi to graph it. We had to graph 3 pedals, and they're all even. So if we graphed into 3 pedals, it's like breaking it up into thirds. This was the first one we followed right here. So if that was the first one, that was from 0 to pi over 3. And so the second one that we made was this one right here. And so that one would be from pi over 3 to 2 pi over 3. And the last one would be 2 pi over 3 to pi. Just using our brain and kind of figuring it out. Let's double check what he said here. So if we go window and we graph pi over 3 to 2 pi, didn't hit the button, 2 pi over 3, hit graph. Oh yeah, it gave me just the bottom pedal like we thought. Kind of makes sense what we're doing there. It is guess and check today. That's going to be a big skill, is utilizing what we had. Okay, we have a calculator. Max could have just plugged in some numbers, but he used his brain first and tried to use the 2 combinations there to get him with his answer in as quick as way as possible. Good? Let's go to Bill. Or go to notes, sorry. So in notes today, in Calculus BC, you eventually are going to find the area of cardioids, limacons, and roses. Okay? It's a little bit of a challenge at first glance, but we are trying to get you prepared for it. Okay? To find the area of any of these shapes in calculus, you're going to work from the center to the edge of each shape with a line segment to find the area. Okay? So for example, on this first shape, I kind of drew those lines in. We start here at this spot and I work out and I work out and I work out and I work out and I'm working and I'm finding all of those and then adding them up to find me the area. Does that make sense? Super pretty. Super pretty. All right. So that's the process. We are going to find a single continuous interval that highlights the portion, I'm guessing that meant portion, of the graph that is traced only once. All right. We're going to confirm with our graphic calculator. Again, you're going to have your calculator. We're going to use some math. We're going to use our calculator, and then we're going to use some problem solving to help us find each of these answers. R equals 4 sine theta. That is this graph right here. Okay, it's a single petaled rose, if you want to think of it like that, or a circle. You're going to start here at the beginning and work your way out. What is the radius of the first line that we made? As I work my way out. So think about it. This line right here. What's the radius of that line? Oh, it's a bad question as I look at your faces. How about 0? Would you say that I start at a really small radius and then work my way out? So the first radius that I need to deal with is 0. That would be this very beginning. I would start here and not make anything. So we want to know when the radius is 0. As I continue to work my way out, what is the last radius that I'm going to make here? 4. So if I know when this equation gets me a radius of 0 and it gets me a radius of 4, that'll tell me the 2 starting and stopping points. Let's try it. If I solve this, 4 sine theta equals 0. If I want to solve, divide by 4. Divide by 4. Sine of theta equals 0. I want to get rid of sine. To get rid of sine, inverse sine. Inverse sine. When is theta going to get me 0? 0 and pi. Those are the 2 places that sine is going to get me 0. So those are the two options I have here to get me this dot right there. It's either at 0 or it's at pi. Then we made these lines and we kept going around until we got to here. We said that the radius of this line right here would be 4. So we took this equation, set it equal to 4. We're going to solve it. So to solve it, divide by 4, divide by 4. Sine of theta is going to be equal to 1. Inverse sine. Inverse sine. We solve that thing. Theta is going to be equal to, when is sine going to get me? 1? Pi over 2. Technically, we could also have a radius of 4 if theta was negative 1. Okay, because if it was negative 1, then it would shoot across the other side. It would look like a radius of 4, but it would really be a negative 1. It's kind of strange. So we're not going to see it today, but technically we could do plus or minus 1. When would sine be negative 1? 3 pi over 2. And you'll see here in a second why that matters. Which two do you think it's going to be? I got to pick one from here and one from there. Which one of these two do you think it's going to be? 0. Which one of these do you think it's going to be? We're using our brain. We guessed. We did that. We did some math, then we used our brain and guessed. Now we're going to use our calculator and see if we're right. Okay, so let's go to our calculator. We're going to y equals. Okay, we are typing in that equation, 4 sine theta. 4 sine theta. Let's graph it. Oh, I got to change my window because I had it messed up. But my window, let's go from 0 to 2 pi. We graph it. Boom, it goes around. And if you notice, we really went around twice. Let's hit the trace button. If I hit the trace button, oh yeah, I'm starting down here at the bottom. That's where I want to start. Okay. If I hit the arrow, I'm going around from 0. I go around, I go around, I go around to right there. That's where I want to stop. Well, look at my theta. My theta right here says it's 1.56. What do you think 1.56 is if we're talking about radian angles? Pi over 2, right? 1.56. That's like 3.14 cut in half. Okay, so we think it's 0 and pi over 2. Well, let's just plug it in then. Okay, we looked at it. We used the trace button. Now let's do our window. Let's go from 0 to pi over 2. We thought that was going to be right, but let's just check. Nope. Yep, that's what we wanted. That was correct. 0 to pi over 2 is what I wanted for that one. So how could I make this circle? Well, I would need to find the area between 0 and pi over 2. That is what I'm looking for to find that area. That's the place, that's the interval of time that I would have to find this area from. Questions on the first one? Let's do the second one. To make it easier to see on your calculator, instead of this one, let's do r equals 6 cosine 2 theta. It doesn't do anything besides just make you not have to change your zoom. Okay, so r equals 6 cosine 2 theta. So if I'm looking at this graph right here, again, we're thinking it's 6. It doesn't change anything besides the zoom. I want that pedal right there. So again, remember, to make this graph, you start at the origin and you work your way out with these lines like this, and we would have to go all the way around. Okay, so we would start here and go all the way around. What is the starting radius that I want to make that graph? 0, because I start like right here in the middle. What is the ending radius that I'd want to end on this graph? 0, because I don't. If it were 6, I would stop up there at the top, but I'm not stopping at the top. I'm going all the way back to the bottom. So I'm going from 0 to 0. Understand where those are coming from? Let's do it. So we're taking 6 cosine 2 theta, and really all I want it to be is 0. That's all I want. I don't want it to be anything besides 0 in this case, because I'm starting at the middle and I'm going to end in the middle when I get done with my shape. We're going to solve this guy. So if I want to solve this thing, what do I want to do here, Dahlia, to solve it? Divide by 6. We divide both sides by 6. I get cosine 2 theta equals 0. Then what? Good. Inverse cosine is next. So she's doing inverse cosine here. Inverse cosine. So she's thinking about everywhere that cosine gets me 0. Well, cosine would get me 0 at what 2 spots? Pi over 2 3 pi over 2. Cool, we needed that. Still got to keep solving, not done yet. I get this 2 right here. What does that 2 in front of everything? What does that 2 represent? 2 times around. We did it all the time. Back in December, 2 times around. We need to add 2 pi. So to add to this, I'm really adding 4 pi over 2. That's what I'm adding here. So 4 pi plus 1 pi would be 5 pi over 2. 4 plus 3 would be 7 pi over 2. Am I done? Nope. What else do I need to do? Divide everything by 2. So my answers here, my theta are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. To get my shape, to get that yellow petal on the top, we're saying that we need 2 of those. There are 2 different spots where I get 0. Looking at it right now, do we have any guesses to which 2 you think it's going to be? Aaron? Why would you guess the last 2? So you already looked at the graph, right? Yes, looking at a graph would be helpful because without looking at a graph, you might guess wrong. That's why we use what we know, what we're looking at, and what we can do with our calculator. So we might guess wrong. Let's type it into our calculator and see. Okay, again, I'm going to change my window back to normal, so 0 to 2 pi. Let's go to y equals. I'm typing in 6 cosine 2 theta. If I watch my graph goes pretty quick, but you can see how it graphed. Aaron said it was the last 2 made, so it started here. Hit the trace button, and you can follow it. It started there and went around to the middle, around to the left, around to the top, and back to the start. Okay, so those were the values I was following. So let's think about it. Okay, if we started here, this right here is the first time my radius is 0. So that would be represent pi over 4. We go around again. We hit the center again. That would be like 3 pi over 4. We go around again. We hit the center again. That would be like 5 pi over 4. We go around and hit the center again. Oh, that would be like 7 pi over 4. So which 2 do we want? Well, we wanted this 5 pi over 4 to start and 7 pi over 4 to end. And then we get back to the start. So that's our guess. Okay? We used our brain. We used our calculator to figure it out. But we're guessing it's 5 pi over 4 and 7 pi over 4. If we want to see it, we hit the window button. We type in 5 pi over 4 and 7 pi over 4. We hit graph. Oh, yeah, it gave me the top part like I wanted. Makes sense what we're doing there. There's not one skill that's going to be perfect. We used some math. We used our brain. We used our calculator. All right. Try the next one. Try the next one. Now that we've gotten a little bit of start with me, see if you can figure it out with your neighbor. See what we need to get just that green section of the graph. What 2 radiuses do you want here for the start and the end? What's your starting radius going to be? Think about it. You're working from this way out. What's the first radius we need? 1. That radius right there would be 1 to get to that part. And then I would keep going around. What would the last radius that I want need to be? 1 and 5. So I want to know when this thing is equal to 1 and when this thing is equal to 5. Go ahead and try to figure out what those would be. All right. We were trying to solve this thing. I went ahead and solved it for you. I subtracted 3 divided by -2. Then I'm going to do inverse sine. William, when is sine going to get me 1? At pi over 2. And if I solved this one, you're doing inverse sine, William. When is sine going to get me -1? 3 pi over 2. I only got 2 options. Does pi over 2 and 3 pi over 2 make sense for this graph? Yeah, because think about it. I'm starting here. There's no crazy loops in it. This one's not a crazy one. Okay, it's pretty straightforward. Cardioids, limacons without a loop here are going to be your best friends. We're guessing it's those 2. Let's just make sure. Okay, so again, we go to our calculator and see what we can do. So it was 3 minus 2. Was it sine or cosine? Sine, right? Sorry. Sine theta. Evelyn, we close the door for me. We hit graph, but we got to change our window back to normal, 0 to 2 pi, just so we can see the basics. 0 to 2 pi, we get that graph right there. We only want the left-hand side. We said that if we graphed it, it would make sense. Well, let's just trace it first. Let's see if the trace makes sense. All right, when do I hit right here? We thought it was pi over 2. Yeah, 1.45, that sounds like pi over 2. You can always hit trace, and then you could just type in pi over 2. Oh, yeah, that gets me that top part like I wanted. And then I could go trace, and then second, or not second, but 3 pi over 2, trace 3 pi over 2. If I hit enter, oh, yep, that's the bottom. Those both make sense to us. Okay, they're in the right spot. If you want to then check it, window, pi over 2 to 3 pi over 2. Graph, boom, that's the portion we want. That's my answer. We're going from 0 to 3 pi over 2. I'm sorry, from pi over 2 to 3 pi over 2. Question so far? Thumbs up, you're doing great. Thumbs down, you're doing terrible. Show me a thumb. Yeah, it's weird. Don't feel like it has to be perfect yet. Okay, again, I'm giving you the tools necessary to help you out a little bit. Okay, we can't connect this all the way to the calculus yet. R equals -3 sine 3 theta. R equals -3 sine 3 theta. Think about this, guy. What are the 2 radii I need to make in order to get me this single petal over here? Just 0, because I'm starting at 0 and then I'm working my way back to 0. So I want to know when that is 0. Go ahead and see if you can figure that out. So I set this thing up. I set it equal to 0. I divided by -3. I did inverse sine. When is sine going to get me 0? 0 pi and then 2 pi. What is this 3 in front of everything going to tell me? Goes around 3 times. This is what I got the first time around. Then I'm going to go the second time around. To find the second time around, I'm adding 2 pi to each of these. So if I add 2 pi to 0, oh, I get 2 pi. I already got it, so I'm not going to list it again. 2 pi plus pi would get me 3 pi. 2 pi plus 2 pi would get me 4 pi. That would be the second time around. But I'm going a third time around because I had a 3 in front. So if I add 2 pi to 3 pi would get me 5 pi. And then 2 pi plus 4 pi would get me 6 pi. Everybody good to there? What else do I still need to do? Divide by 3. So if I divide everything by 3, I get 0. I get pi over 3. I get 2 pi over 3. I get pi. If I divide that one, I get 4 pi over 3, 5 pi over 3, and 2 pi. Everybody good to hear? We got to figure out which ones it is. Why are there so many here? There's a lot of answers. Anybody think they understand why there's going to be a bunch of different answers here? It goes around twice. Remember when you have an odd number of petals, it starts to repeat. And so you might not know it, but those don't matter because it's what you get the second time around. So we could kind of just cancel those out. I really just care about 0 to pi. You could find that out anyways. You use your brain to get to that point. But there we go. All right, let's graph it. Again, I'm going to change my window back to 0 to 2 pi because that's what we're about to attack. You could do 0 to single pi if you'd like. I'm going to go y equals. I'm graphing. What was the equation again? -3 sine 3 theta. Thank you. Cool. We hit graph. Ugh, it goes so fast. I'm going to hit the trace button so I can actually follow what's going on. So we started here in the middle. That was like 0. And then I went over here to this rose petal. Then I went through to the top. And I went through to the side. Back to there. Okay, then I start repeating after here. Look at the theta. Right there, that's 1 pi, 3.15. And then we just start going on the loop again. Okay, so we don't need that second loop anyway. So we really just care about 0 to pi. It gets me the same graph. So think about it. I've got 0, pi over 3, 2 pi over 3, and pi. Let's go around the loop. So if I go trace, there's the first one at 0. We go around. We hit the center again. That's pi over 3. We go around. We hit the second again. That's 2 pi over 3. That's the loop I want. That's the loop I want. All the way back to pi. 2 pi over 3 to pi were the 2 that I want here. That is an interval of time where that's going to be true. Questions on how we came across that. Again, we used math, we used our brain, we used our calculator. The combination of those three things were helpful to get us an answer. We good? That's the skill I need you to get from today. Let's go to the backside. The backside is definitely going to help you next year with calculus. Okay. The first skill, we'll do a little bit on our quiz, on our test coming up. Not a ton. If you can do that, if you're at 80% right now, you're going to be fine. Okay. The backside's weird. Don't stress out too much about the backside. Let's say I asked you to find the area of the shaded region. Okay. Not thinking about polar graphs at all. But if I just gave you that shape and I said, find the area of the shaded region. Tell your neighbor, what would you need to know and how would you need to set it up? What would I need to do in general? Anybody have an idea? What would I need to do in general to just find the area of the shaded region? You do this on the SAT as well. Morgan?
You would find the area of the full circle
Area of big shape.
and then take out the small circle.
And then you would subtract out the area of the loop. You agree? Area of the big shape minus area of the little shape tells you the shaded region. That's what we're going to do. Okay. When you get to this next year in calculus, that's how you're going to approach that. Let's look at some examples of that. Okay. This is a skill you need to know. What is the intersection point of these two graphs? I graphed two things for you. I graphed a cardioid. That's the green shape. Let's color code. That's the green shape. Okay. Then I graphed you the circle. R equals 2. That's the black circle. I want to know when those two things intersect. What is the intersection point of those two things? How can I tell when two equations intersect? What would I want to do? Evelyn? Set them equal to each other. If you want to know when two things are equal to each other, set them equal to each other. So let's do that. So if I'm doing this one, I'm taking 2 minus 2 cosine theta. I'm going to set it equal to 2. I'm going to solve. Minus 2, minus 2. Divide by negative 2, divide by negative 2. When is cosine of theta going to be equal to 0? At what two spots is cosine of theta going to be equal to 0? Pi over 2 and 3 pi over 2. I needed two intersection points. I got two values. Do you think that guy right there is pi over 2 and that guy right there is 3 pi over 2? I agree. They are. We could use our calculator and double check that. But if I want to know when two things intersect, I set them equal to each other and I solve. Make sense on that part? Let's go to the next one. Let R be the shaded region that is inside the graph of R equals 3. So R equals 3 is the green circle. That guy right there. And inside the graph of R equals 3 minus 2 sine 2 theta. That's the little lemniscate kind of looking guy. Kind of look like a peanut in the end. How can we find the area of R? Think about it. Think about what would happen here. Remember, to find the area, you start in the center and you work outwards. Talk with your neighbor for a second. You're going to need two different equations here. Think about what two things would you need to talk about? What would you need to know? Just talk. Think about it. Let's look. What do you notice about this area? This yellow shape. It's a weird shape. What can you tell about the construction of that shape? It's a terrible question. Terrible questions. Would you agree that it's really made up of two different shapes? Yeah, that was an awful way of me saying that. Okay. Shape number 1 is this guy right here. Right? This guy right there. That's shape number 1. We need to find the area of that shape. The other shape we need to find is the area of this shape right here. Okay, because think about this. If I were to work from 0 and go around, I'm making these lines. I'm going from here to here, to the red line, to the red line, to the red line, to the red line. Then what happens right there? It intersects. We switch which line we go to. So we're going to keep drawing lines, but now I'm from the center out. I'm from to the green, to the green, to the green, to the green, the rest of the way. The first area, the first guy, what is the equation that I'm touching? What is the line that I'm touching there? 3 minus 2 sine 2 theta. So you would want to find the area of that guy. 3 minus 2 sine 2 theta. We don't know how to do that yet, but in calculus we would. From when to when do I want to find the area of that shape? 0 to pi over 2. Because pi over 2 would be, yep, right there at the top. So I would want to know what this area is. I would find the area of that equation from 0 to pi over 2. Whatever I find for that answer, I'm going to add to that the area of this shape that I drew really poorly. But imagine I could draw. We can do that now. Find the area of that shape without me telling you. You don't need calculus for that. Find the area of that green shape there. Go. What shape is that thing that we're making here? Quarter circle. So it is pi r squared. It's a circle. Area of a circle is pi r squared. We could talk about intervals and do all that stuff, but why? We could just find that area without anything else. What's my radius going to be? 3, because I'm going from 0 to 3. Well, that's not going to get me the right answer. What else would I need to do? Divided by 4. I take whatever this is using calculus plus that stuff using algebra or using geometry. We got our answer. Makes sense on how we're doing that. It's a little complex. That's okay. All right, we're going to skip that last one just for time's sake. That's what we're doing, okay? Eventually, you'll need that in calculus. What I need you to know from today is the first part. Can you set up the intervals? If you can do that and use your calculator to get an answer, great. Okay, understanding the backside, knowing where it's intersecting, and how to make a shape from different shapes, we're going to do that eventually next year. Homework assignment.